Alright, 6.5, solving problems using quadratic equations. Basically, we're looking at word problems that deal with different types of quadratic equations and how to solve them. Example 1. The population of a city modeled by the relation p equals 0.5 t squared plus 10t plus 200, where p is the population in thousands and t is the time in years, t equals 0, corresponds to the year 2000. Okay, so t is the time in years from the year 2000. So if you look at 0, 0 corresponds to the year 2000. That's what it says here. Now, part A, what is the population in 2000? Part B, what is the population in 2012? And part C, when is or was the population 350,000? So we'll work on that. Now keep in mind something important here, that P is the population in thousands. Keep that in mind when we're answering the questions. So part A says, what is the population in 2000? To know that, we have to sub T equals 0, because that is the years from 2000. If we want 2000, we need 0. So T equals 0 means that P equals 200. How do you know? Well, when I plug in 0 for t here, this is now gone. I plug in 0 here, this is gone. And I get the number 200. That's the leftover. That is also essentially the y-intercept. If we were to look at a graph, it would be where it would cross the y-axis. The idea is that when you plug in 0, the 0 will cancel anything with the variable so that you have just the constant left over. So p equals 200. What does that mean? Was the population 200 or, that's right folks, the 200,000. So therefore in 2000, the population of the city was 200,000 people. Alright, part B says the following. So we need to know what is the population in 2012. So what are we subbing in for t this time? That's right, folks. We're subbing in t equals 12. We plug in 12 for t. We plug it in, and each time we see a t, we plug in 12, and we get the value of 392. So therefore, in 2012, the population was 392,000 people. Now, the last part. When is or was the population 350,000? So what are we going to plug this in for now? Hopefully you're thinking, okay, we need to plug P equals what value? That's right, 350, and that's it. Not 350,000, because remember, P is the population in thousands. So many thousands are in this number? Well, there are 350 of them. So that's why we're plugging in P equals 350. We plug it in. P equals 350. 350 equals 0.5 t squared plus 10t plus 200. What do we do now? Well, what we're going to do, okay, is we need to move the 350 over so that we have 0 equals 0.5 t squared plus 10t minus 150. And then what we're going to do is either factor or use the quadratic formula to solve for t. So a equals 0.5, b equals 10, c equals negative 150. You plug it into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac. And you plug in the values. Don't forget to show the discriminant. And once you show the discriminant, you plug it. You can then do the plus or minus part of it. And we get t when you add it will equal 10. T when you subtract will equal negative 30. What does that mean? Well, that means that the population was 350,000 in what years? Let's see. 10 more from 2000 and 30 minus from 2000. So, was in 1970 and in 2010 the population was 350,000. Okay, so again one more time. If it's positive 10, remember, from the year 2000. That means 2000 plus 10. And then for the negative 30, you take 2000 plus negative 30, and that gives you 1970. So you got 2010 and 1970. This is when the population was that. Now, some of you may be wondering, how come the population was the same in those 40 years apart? Well, look at the equation. The equation opens up. That means that when you look at a parabola and you're looking at it in terms of upwards, what happened is the population in 1970 was probably on its way down, and then in 2010 the population was on its way up. So it's a model of a population of a specific city and things that happen over those years. All right, moving forwards. We've done this question. Let's look at another one. Here's example number 2. Example number 2 says the height of a toy rocket launched at a 3-meter platform can be modeled by the formula h equals this equation, where h is the height and t is the time after its launch. So we're looking at height in meters because it says 3-meter platform, and t is the time, and let's say it's in seconds. So how long would it take for the rocket to fall to the earth? What is this question asking? Well, this question is asking at what time is the height 0? So the height is 0 at 2 specific times. Now when we calculate it, we're going to use the quadratic formula, and we use the quadratic formula to plug it in. All right. When we plug it into the equation, we get certain values. All right, plugging it in again. And when we plug it in, don't forget to show the discriminant, which is inside there. And you will get the 1. When you add them, the value will be negative 0.0498. When you subtract them, will be 12.2947. So what that means is that this is the time at which it reaches has a height of 0. One of these is logical and one of these is not. Can you see which one that is? That's right. We can say safely that the toy rocket reaches the ground at 12.2947 seconds. We can actually ignore this value because you can't have a time value that is negative. All right, part B says, what is the maximum height of the rocket? To find that, we need to find the vertex. How do we find the vertex, folks? Well, we could go back and try to complete the square, probably get some pretty ugly numbers here, or we could use the information we have in part A to find the information in part B. How do we do that? Well, you know that each point that has a mirror image. So this is a point and its mirror image is on this side. These 2 points, when you add them up, and yes, you have to include the negative, add them up and divide by 2, that will give you the axis of symmetry. So that will give you the time at which it reaches its maximum height. Now, to find the actual maximum height, you would then plug in the value for t that you found into the equation to find the value of h. So, here's how we would solve it. For part B, we would take the t values yet again. So those are the t values we had earlier. And we would add them up and divide by 2 to find the axis of symmetry. We add them up and divide by 2, and we get that the t value is 6.12245. Now, we sub in that t value back into the equation, sub it in for t, and we find the h value. Our h value, once we plug in 6.12245 into the equation, we will get an h value of 186.67347. So rounding it, we would get the maximum height is 186.6735 meters. And that's how you would do that if you already have values. So it doesn't make any sense to complete the square when we don't need to. Part C. Over what time interval is the height of the toy rocket greater than 150 meters? So let's look at what we have to do. We have to set h equal to 150 and plug it into the equation. Once we do that, you move the h over to the other side, and you get a value of, so again, we need to find those values. So we plug in a value for A, B, and C, plug it into the quadratic formula, and we get the value, plug it in. Now don't forget, when you plug into the quadratic formula, you should always show the discriminant value. The discriminant is not the whole thing, folks. It's what's found underneath the root sign. Only what's under the root sign is called the discriminant. So when we add them, we get 3.3867. When we subtract them, we get 8.8582. What that allows us now to do is that gives us the two intervals. How do we understand this and why is it like that? Well, think about it this way. The parabola opens like this, and on its way up, this is the time at which the rocket is on its way up, and this is the time at which the rocket is on its way down. So it's the idea that it reaches a certain height of 150. So the 150 mark is here. Let's say 150. Sorry, folks, 150. And then it reaches it on the way up and on the way down. Those are the two times. Now be careful. This says over what time interval. So I could just write the time. The rocket is above 150 meters from 3.3867 seconds to 8.8582 seconds. I might change this question and say, how long is the rocket above 150 meters? And for that, we would subtract these values to find how long it is above that 150 meter mark. All right, next. Example 3. The product of two consecutive numbers is 272. What are the numbers? So the question is, what are the numbers? And we need to find that out. Here we don't have a word problem. So we don't have the equation. So we have a word problem with no equation. So now we need to look at these actual numbers and figure out what will work. So how are we going to do this? Now, the question says the product of two consecutive numbers. So if we let x represent one of the numbers, x plus 1 will represent the second number. Why? Because x plus 1 will be the next consecutive number. Now, x times x plus 1 is equal to 272. What do we do here? We need to expand this. X times x is x squared plus x minus 272 equals 0. So we move everything to one side, make it equal to 0, and then we solve for it. How are we going to do that? Well, we could factor it, or we could use quadratic formula. Either or is acceptable. So we're going to factor this because it's easier and faster, and we find out that 17 times negative 16 gives us negative 72, and we add them gives us positive 1. That means that our actual values are negative 17 and positive 16. That's the values of x after we solve for x. What does that mean? It doesn't mean these are the consecutive numbers. In fact, these numbers aren't even consecutive. One's negative 17, the other one's 16. What we now have to do is find the next number that goes with this. With negative 17 goes the number negative 16. With 16, the next number is 17. So these are your two pairs of numbers. One pair is negative 17 and negative 16. The other pair of numbers is 16 and 17. And these are the different pairs of numbers that satisfy the problem in the beginning. All right, next item on the agenda. Let's look at another word problem that doesn't have the equation given to us. Example number 4, the hypotenuse of a right triangle measures 10 meters. One of the other two is 2 meters longer than the other side. Find the side lengths that we're looking at here. So, the hypotenuse of a right triangle measures 10 meters. One of the other two is 2 meters longer than the other side. Find the side lengths. So we have a triangle, and it's a right triangle, so we use a little right angle to denote that. And now we have to fill in the information. So as the hypotenuse of a right triangle measures 10 meters. Where is the hypotenuse located? That's something that students have a difficult time understanding. A lot of times they just say, oh, it's the longest side. What happens though, just out of curiosity, if our longest side didn't really look like it was the longest side? So let me just change our triangle around like this. Now, which one is the hypotenuse? Well, if you're looking carefully, this side should be the hypotenuse. Right there, folks. That is the hypotenuse. How do you know? See this right angle? He actually points to where the hypotenuse is. It doesn't matter how you rotate the triangle. I could rotate it this way. This right angle always points to the hypotenuse. Always, folks. So it doesn't matter what I do. This right angle is always going to point to where the hypotenuse is. So let's bring it back. And now identify the hypotenuse. And looking at the right angle, this points to this side, so that must be where the right angle is. The hypotenuse is. 10 meters is that side right there. And then one side measures x, and the other side measures x plus 2. What do you have? You have Pythagorean theorem that says that this is satisfied. X squared plus x plus 2 all squared is equal to 10 squared. That's Pythagorean theorem. Expand the expression, collect like terms, bring everything to one side, and we get something like this. What we want to do here is common factor, folks. We do want a common factor, and see if we can factor that, which we can, lucky for us. And once we factored it, what this does is it tells us, okay, I know the x value. X must equal -8, or x must equal 6. How do you know which is correct, and how do you know which will make more sense? Well, what is x? X is a side length. Here, -8 doesn't make sense, so we would cross the -8 out, and we're only looking at 6. So x plus 2 is equal to 8, where x is equal to 6. So the side lengths are 6 meters and 8 meters long. So the goal here is to find a problem that works. For anything that involves a right angle, we're looking at Pythagorean theorem, so don't forget that. All right, next. Example number 5. A rectangular park measures 100 meters by 60 meters. A path of constant width is to be paved around the perimeter. The mayor wants to be sure that the path does not reduce the area more than 10%. What is the width of the path? And then round your answer to the nearest tenth of a meter. All right, let's look at a drawing. All right, first we want a rectangular park, and there it is. And we know this rectangular park has dimensions 100 by 60. Okay, now that we have the rectangular park that's 100 meters by 60, we want to create a path. This path can be is equal width all the way around, and knowing that, how much park is left over? Well, remember that we're building the path on the inside of the park. We're not going beyond the park, we're building it on the inside of the park. So, knowing that, that means we have measurements of x from here to here. That's x. See, there's a little x here. X is here to here, all the way across. All this width here of this path is x, all the way across. So, the measurement of the park on the inside is now going to be 60 minus 2x, and 100 minus 2x. Why? Well, again, the whole park was 100, and then we're taking away x path on either side. The same goes this way. The whole path was 60, and we're taking out x part from either side. So that's 2 x's that are being taken out. So 100 minus 2x and 60 minus 2x. Once we do that, we have to now set up an equation. So we know I have 100 minus 2x and 60 minus 2x. What will that area equal to? Well, remember, the question says the path does not reduce, the mayor wants to be sure that the path does not reduce the area more than 10%. So how much park is now left if it's no more than 10%? Let's say it took up the maximum 10%. Well, that means I have 90% of the original park left. 90% as a decimal is 0.9. And then we multiply it by the original park, which is 60 times 100. So again, this is the area of the inside rectangle. That is the remainder of the park. And that's what the shaded part is. We have 90%, 100 minus 10% is the park minus the path, the whole original park minus the path. And this is the area of the original park. And what we want to do is find out how much of the park is left. So once we know that, we can solve this problem. So we're going to erase all those pieces right there. And we're going to come back to the equation that we're looking for, okay? So 100 minus 100 times 60 is 6,000, minus 200x minus 120x plus 4x squared equals 5,400. Move everything to one side. You have 4x squared minus 320x plus 600 equals 0. And then 4 times bracket x squared minus 80x plus 150. And then factor. Now, can you factor this? You could try, but I'm going to tell you right now, folks, it's not factorable. So we have to use, that's right, quadratic formula. A is equal to 1, B is equal to negative 80, C is equal to 150. And we plug in these values into the quadratic formula. Don't forget to show the discriminant, which is found under the square root. Show me that value. And then we add, and we get 78.0789, and minus, and we get 1.9211. So, I want you to understand something. Which one of, now both of these values that you have here, both of these values, this one, and, okay, so this one and this one are both positive, but only one of these is valid. Let's think about it. If you have a 78-meter path, that's going to eat right into the 60 meters, folks. There's no way you could have two 78 meters paths when you only have 60 meters to work with. So logically, this one is not even a valid answer. The valid answer is this one. So you will say, therefore, the path's width can be no more than 1.9 meters wide. And the reason why we rounded it, because it says round to the nearest tenth. Alright, that's the end of the video, folks, and all the different types of word problems. Have a numerical day.